And although the first formula, it's nice to think that you will be proactive and start saving money and start building up money, when real life happens, you will more often run into this formula where somebody has given you a loan or given you a mortgage and you're paying them interest because you wanted to buy something before you had money to buy it. This is more realistic in life, okay? Most of you probably don't have a bank account right now that's like, oh, I've just about got $400,000. I think tomorrow I'll go buy a house. Okay? That is not the situation, right? Some of you are like, oh, I've just about got $400, but not $400,000. Okay? So we're going to use this formula more often, which is you get an amount borrowed. They give you some money. That's your present value. You can afford to pay a certain amount per month, and they charge you an interest rate, compounded monthly or compounded quarterly, and you want to find out how many payments you're going to need to pay something off. So the first example that they have here, in example 2, is you're buying a car. And for some of you, you might have done this already. And for others, you're thinking of doing it. And maybe for some of you, you've got a car that you're paying for, but your parents actually did the finance. So what does it look like? Again, you would be given this formula. That formula would be given to you, and again, it would explain everything, including that the I value is your interest rate divided by the number of compounding periods. And we would plug everything in. This time, you're borrowing $15,000. So the present value is you owe $15,000. You can afford to pay $300 a month. And they say, we'll give you an interest rate of 6% compounded monthly. So we plug everything into the formula just like before. And again, I'm going to use a green box and say, there's my power in this formula. I, first of all, need to do some modifications to get that by itself. So just like last time, I'm going to take out my calculator. I'm going to get rid of this dividing by multiplying both sides by 0.06 divided by 12. You get 75 equals 300, square bracket, 1 minus 6 by 12. And still want to get that by itself. Next, I would have to divide both sides by 300. And I get 0.25. Square brackets aren't needed anymore. I can now move the 1 over to the other side by subtracting 1. I'll get negative 0.75. I find that this is an interesting place for a mistake. Okay? You subtracted the 1. For whatever reason, when students subtract the 1 to this side, they're like, oh, I don't like that negative. Maybe I'll just ignore it. No, the negative is still there. Okay? That negative will still be here when I subtract 1 on both sides. And technically, I do not have the power by itself yet. That's another mistake. You see a negative like, oh, it's by itself. No. It's only by itself when it is by itself. That negative, we have to move the negative over to the other side. So we would have to multiply both sides by a negative. And now the power is by itself. I'm going to zoom out just for a second here. And I'm going to show you something interesting that happens. This question is usually worth 4 marks to solve. They would give you, on the provincial exam, when they decided where do the marks go, which is kind of a guide for how grade 12 teachers are supposed to mark when they give you questions, okay? Plugging in all the right numbers, they say, good job, you get a half a mark for that. Then, all of this work to get the power by itself is considered work that you did in grade 10 and 11. Isolating a variable, doing order of operations, that's nothing new. So all of this work, sometimes on a final exam they didn't give any marks for it, and would just say, we'll take off a half a mark if you screw up. And sometimes all of this work of getting that power by itself, they would say, that's a half a mark. Then this next step, which looks like this. What would you do next? You want to solve, you're going to have to take the log of both sides. Take the log of this side. And probably some of you are getting good at your log laws that you would say, well, I'm going to take the log of this side and I'm going to bring my power out in front at the same time. Perfectly fine. Okay? Okay? This step that I just wrote is worth 2 marks. They give you they used to give you on the provincial exam, if you knew to take the log of both sides, that's a new concept in grade 12. Whenever you do something new in a grade, that's usually a 1 mark thing. So you took the log of both sides, that's 1 mark, and you used a log law that brought the n in front, that's your 2nd mark. So it's not proportional to how much work it takes. It took a lot of work to get the power by itself, but they considered that work stuff that you knew how to do from before. Then when you did the next thing, that was all new grade 12 concepts. You got a mark for each new grade 12 concept. So you got 2 marks for this. And then the final mark would be getting n by itself. It's getting a little small, I'm going to zoom back. The final mark would be getting n by itself, so you'd have to divide by the negative and the log of 1 plus 0.06 divided by 12. And we get n equals 57.68. So the question was, how many payments would it take you to buy this vehicle? It would take 58 payments. That would be 57 full payments, and you're paying $300 and 1 partial payment. And if we want to figure out exactly what it would be, I've got it in there right now, I could take 57.68 and times it by $300, and we find out that this car is going to cost us $17,304. So if you want to buy that car for $15,000 and someone says, how much did that car cost you? Our normal thing to say would be, well, it cost me $15,000. But in reality, you're paying more than $15,000. You're paying either the car company or the bank an extra $2,300. So knowing that is important, because knowing how much you're going to pay for something in total might make that decision different. Probably in this situation, you're like, but I need a car to get to work, and if I don't get to work, I don't make any money. So yes, it makes sense to pay a little bit of extra money, right? Because if I don't have a car, I can't get to work, and if I can't get to work, I can't make money, and then then I can't do anything with that, right? So I do have to pay a little bit extra for my car, so I get to work, so that I make some money to pay off my car. And eventually my car will be paid for, and then I'll just have the money from my job to pay for repairs, or whatever else comes up, okay? Now, I'm going to show you on if you have a graphing calculator, I'm going to get you to take it out. And if you don't have a graphing calculator, I'm going to tell you there are lots of apps online that will do this, okay? So if we hit the apps button on your graphing calculator, the very first one is Finance, push enter, and the very first one is TBM Solver. And we're going to make some notes because although you have to solve for these questions algebraically, just like we did, sometimes it's nice to have your calculator to check your work, okay? So the TBM Solver stands for time, value, money. If you type TBM Solver into Google, you will get an app or something online that does something very similar. I'm going to show you how the graphing calculator one works, because as far as the thing that I've used my graphing calculator the most outside of teaching high school math is using this program. Because every time I go to buy a new car or I'm looking at how much money am I paying for my house, this app gives me answers very quickly and can help me save money. So, first of all, what we're going to do in our notes is we're going to just write out what each of the things stand for in the TBM solver. See, I think I've got them in the same order. Yes. So, the N stands for your number of payments. The I is your interest rate. But in this case, it's not a decimal. So if it's 7%, you just write 7. You don't change to 0.07. The present value is PV. PMT stands for your payment. Future value for FV. P per Y is payments per year. And C per Y is the compound periods per year. It's a little finicky with positive and negative values, so we make a little note. We're going to use positive values whenever you receive money, slash, sometimes you receive something that's not money. Like, they give you the car. They don't actually give you the $15,000. They gave you the car. But they said that car was worth $15,000. So technically, they're giving you $15,000. Okay? And we use negative values whenever you make a payment or investment. In other words, whenever you give money away. So I like to imagine, am I getting something? If I'm getting something, and you can put it, well, I can't necessarily put a car in my pocket or a house in my pocket. But if I'm getting something that I get to have, that's a positive thing. When I'm giving money away, and that can include taking $200 and giving it to the bank to put into an investment, whenever it's going from my pocket somewhere else, it's negative. When the bank gives it back to me, it's positive. So we're going to look at how we can solve this question that we just did with our calculator. Now, the question was asking us to solve for how many payments would you have to do on this car. So the end value is the one that you don't know. You can have any number in here that you want, it won't matter right now. But we do know that the interest rate was 6%. They gave us the car that was valued at $15,000, so that is going to be positive. But we are making payments of $300. That will be negative. The future value, we don't want to owe them any more money. The future value will be 0. Payments are monthly, compound is monthly. If it's on end, we will leave it on end. And then you can go to the one that you don't know. And above the enter button on my calculator, it's green, it says solve. Push the alpha button and enter. And it gives us that 57.68, the same that we figured out with all of that math. This can be really helpful because if you are sitting in a car dealership figuring out, is this a good deal for me? Doing something on your phone or your calculator quickly to figure out something is okay. Okay? Probably not the place to go, you know what? Let me do some logarithms. As cool as that would be, and I'd be super proud of you as a former student, right? Yeah, probably not. I'm just going to solve some logarithms here to figure out how much I'm going to pay. They'd be like, there's an app for that. That's quicker and makes more sense. Should probably use it. Okay. So they've got the values. Usually the people selling you the car don't always necessarily know how to use the app really well, so it is something that you want to be comfortable with. And you figure out that it was 57.68, and in your calculator, you can right away go to the end here. You can do math right into this program, like say, okay, so if I times that by $300, how much am I paying in the end? Oh, I'm paying $17,304 for this $15,000 car. That seems reasonable. Okay? You go to another car dealership. They say, we have the same car. It's $1,000 cheaper, but our interest rate is 11%. Which is the better deal? Okay? Our gut reaction always says, go for the cheaper car. Same car, this one's $1,000 cheaper, but our interest rate is different. Hello? Yeah. So now I'm going to figure out, okay, if I do that, how long is it going to take me to pay this off? 67 payments. Is that cheaper? No, because your payments are still $300. You'd be paid $20,000 for that one instead of $17,304. And one of the things I told you before is that interest rates can make a huge difference. And we're going to really see that today. This is like, I find that today's lesson is probably the lesson that you can use the most after high school. One of my most exciting lessons to figure out, to teach. So that interest rate made a huge difference. Even though the car was $1,000 cheaper, that interest rate made you pay way more in the end. Something to be aware of. Now, if you had $14,000 and didn't have to take out a loan, of course the cheaper one would be better. And you can negotiate things like that, right? I can tell you a story about, I'll tell you right now. We recently bought a car, and they were offering a high interest rate, and I said, I can get a better interest rate from my bank account, but they're like, but we really want you to use ours, because the person who was selling the car, he gets a bonus if he convinces you to go with their interest rates, because they can make a lot of money off interest. So he's like, how about we do a deal where I get the bonus if you keep our interest rate for the first 10 months, and then you can do whatever you want, and I will pay your interest for you, or part of it for that first 10 months. So as long as I kept their interest rate for the first bit, the car dealership is actually paying for the interest. And then I negotiated, then once it's done, is then you can pay, you can switch to your bank if you'd like. If it's a lower interest rate, you can do whatever you want. So you have that ability to negotiate these things, but you have to know what the numbers are so that you're in a point where you can be like, well, this is what I want to do and why. We're going to do the example off to the side because the other big thing that you are going to do in your real life is probably buy a house. So the example that they have right beside this car one is, there we go, you're borrowing $200,000 to buy a house, and you can afford to pay $1,500 a month. The mortgage is 4% annual interest, compounded monthly, and the question is, how many monthly payments will you do for this house? And how much will it cost you? So, what we're going to do, we're going to use our calculator to save us some time. So go to our calculator. We don't know how many months. We know the interest rate is 4%. They are giving us the house if we buy it, and it's valued, that loan is valued at $200,000. We can afford to pay $1,500 per month. The future value, we don't want to owe anything left on our house, will be 0. Payments are monthly, compounded is monthly. So we go back up here, and we go alpha solve, and it says it will take you 176 payments, which is like 14 and a half years, to pay for this house. If you're curious, you can go to this number and say, if I times that by 1,500, how much do I pay for this house? The house was originally $200,000, but I'm going to be giving the bank an extra $65,000. That's a lot of money, okay? Now, in Canada, just some things about buying a house in Canada. Usually, when you buy your first house, the mortgage happens not over 15 and a half years. They make the mortgage happen over 25 years. And that's what you can get approved for. So they say, well, what can you afford to pay? And let's say you say, I can afford to pay around $1,000 a month. They say, well, we'll see if you can afford this $200,000 home. Your number of payments are now 25 years times 12, 300 payments you're going to make. And in this program, you can also go and see, well, what would my payments be? I can go alpha and solve on that one. It's about $1,000 a month. So if you said you could afford $1,000 a month to buy a house, they're like, well, then your maximum amount that you could buy is around $200,000. That's your maximum. And you say, okay. And most people do this when they buy their house. They're like, what's the nicest house I can get for the money that I can afford? You want to spend as much as possible and get the nicest house you can. So you'd be like, okay, I can afford $1,055. How much are you going to pay for this house? Right? Times by 300, because you're making 300 payments. It's a little bit more. It's going to be more than the other one, because the other one you paid off in 16 years. Now you're taking longer. You're paying it off in 25 years. And you find out, we're going to write this down. We're starting off $316,702. And what I'm going to show you right now is some techniques that you can use to save yourself a lot of money. Okay? So first of all, this $200,000 house is going to cost you $316,000 in the end. You're paying an extra $116,000 to the bank. And that is a lot of money. Positive thing though is chances are in 25 years, prices of houses have always over time gone up. So this house, I guarantee you, if you buy a house now for $200,000, in 25 years, it will be worth more. So it's considered, for a lot of things, a good investment, because even the interest you pay to the bank, you get back because the value goes up. So it's considered a good investment that way, because the value of your house goes up over time. But what I want to try to get you to learn is ways that you can pay less to the bank, because nobody likes paying the bank extra money. I want you to keep as much money for yourself as possible. So the first thing that I'm going to show you, and the first thing that I talked to you about before, is if you can spend some time looking around and making sure you can get the lowest interest rate possible, negotiate, right? Usually the numbers are pretty tight everywhere, but maybe you can get two banks fighting against each other and one of them finally agrees to say, you know what? We'll do 3.5 instead of 4. And you spent 8 hours working on this and you're like, was it really worth 8 hours for a half? Right? If you came to me after a test and you're like, okay, well, we're going to sit here, we're going to argue for 8 hours, and at the end of the 8 hours, I'm like, okay, I'll give you an extra half an hour. You're like, that's not worth it. Okay? But is it worth it in this case? Well, we're going to see. You're still paying it over 25 years, but instead of $1,050 per month, it's $1,000 per month. And you're like, again, you're sort of in a short term, you say 8 hours for $50. Was it worth it? Well, if we take this $1,000 now and times that by 300, we're down to 300,374. So that extra 0.5% has already saved you $16,000. Okay? Now, the second thing that can save you a lot of money, and that a lot of people don't take advantage of. So right now, we're paying $1,000 a month. Okay? In total, we're paying $300,000. Most people buy the maximum house they can afford. They're like, the most we can afford per month right now is $1,000 a month. Okay? But when you get your job, you will always start at the bottom. And then the next year, you'll probably get a raise. And then you'll figure out some other stuff, and maybe you'll get more experience, which allows you to apply for a different job, which pays you more. And as you continue working, your salary is going to increase. So now you have more money available. Okay? The most common thing that people do when they have more money available is they're like, woohoo! And they spend more money. Right? You can spend more money on clothes or on a new vehicle or going to Jets game or on entertainment. You've got more money, so you're like, I've got more money, I deserve it, I'm going to spend more money. But I'm going to show you that if you decide to spend that extra money on your house, how much you can save. So let's say instead you're like, oh, we actually got a raise and we thought 1,000 was the most we could spend on our house, but we can actually put another $250 away. So now we can make payments of $1,250. And most mortgages will allow you to raise your amount a certain percentage. So you'll be allowed to raise your payments to $1,250. So you're like, perfect. Raise it to $1,250. Now my question is, oops, go to. Mr. Rowland, please contact the office. Mr. Rowland, please contact the office. Okay, use the negative sign, not the subtract sign. Now you're going to pay it off faster. How much faster? Alpha Sol. Instead of 300 payments, we're down to 215 payments. How much is this house going to cost us now? Times this by $1,250, because I'm now paying more. Look at this difference. We're down to $269,796. From our starting point, We are almost $50,000 less than where we were at the beginning. That's a lot of money. That's $50,000 that you saved. It's not like, oh, it's $50,000, but you paid extra. No, you actually saved that $50,000 that the bank does not get. So there's another way, right? If you can afford to put a little bit more money on your mortgage, that will be huge for saving you money over time. And then another little trick you can do is often when you do their mortgage, they ask you, well, how often would you like to pay it? Would you like to pay it every month or every 2 weeks? Okay? So if I cut this in half to negative 625 and do every 2 weeks instead of every month, the difference with every 2 weeks is that instead of 12 payments times 2 would be 24. It's not twice a month. Every 2 weeks would be 26 payments because there's 52 weeks in a year. So you're going to pay $650, $625 more twice in a year. How much of a difference would that make on our mortgage? It's just a little. Basically, you're paying the same thing every month, but 2 months of the year, you're going to make an extra payment. So again, I go up to here, I'm like, well, now how long does it take me to pay this off? Oops, the compound per year was still going to stay at 12. It's going to be more payments because you're paying them every 2 weeks, but now if we take those payments times 625, we're now down to 261. We just saved another $8,000. $8,000 by just making our payments every 2 weeks, basically twice a month instead of once a month. Same amount, but a couple times per year you add an extra payment. How much of a difference does that make? Now we are over $55,000 saved. And that's money you get. Plus, you save $55,000, and we look at this, 418, right? You're making 26 payments a year. Instead of taking 25 years to pay it, you've dropped it down to 16, which will mean in 16 years, when your friend has decided not to change anything and they're still paying the same amount every month, you now have an extra $1,300 a month. So you may decide to, early on, not buy as many shoes or do as much entertainment, make that decision, but it will give you opportunities later to do more, especially like, what would you do with an extra $50,000 if you had it right now? That would be good. So what would that look like? So I think this is really important math to understand. It can save you money, right? Questions for practice? 7, 12. Right? 25 years from now, if you've saved money from this, and I'm not dead, then you can buy me a coffee. That would be a good thing.